All right, guys, last thing when it comes to graphing trig functions. And then these ones with phase shifts are extremely tricky. So please take your time on these guys and watch the video more than once if you need to, just so you can kind of get a handle on these because they are tricky, icky. All right, so this is a little bit different. This one has the degree in it, and we haven't done a video with a degree in it yet. The graph paper that I'm using is in radians, so I need to get this into radians, okay? If the problem is giving it to you in degrees and the graph that they're giving you is in degrees, then you're fine. You don't have to do this part over, okay? But I need to. So I'm going to go 135 and I'm going to multiply it by pi over 180. Remember, that's how we get into radians. 135 pi over 180, and I think that's 3/4 if I remember correctly. Yeah. So I get 3 pi over 4. Again, these units are by 30 degrees. So if I take this guy 135 and figure out how many units that is, 135 divided by 30 degrees. So this is really 4.5 units, which it totally depends on what graph paper you are using. Okay, so we talked about finding those important pieces, right? So the amp, remember on tangent and cotangent, it's none. The period for tangent and cotangent is 180. I hope you said 180. 180 divided by whatever constant is with the, or I should say coefficient is with the x or the theta. In this case, it's 1. So our period is going to be 180 or just pi. Okay, and then we remember we can say something important is happening. What do? We divide that value by, hopefully you said 2. So everything else we divide by 4. Tan and cotangent, we divide that guy by 2. So something important is happening every pi over 2 or 90 degrees, whatever you like. Okay, the shift. Now this we talked about once before. They like to sometimes put this 1 in front, which does not really match the y equals a tan bx plus c plus d kind of formula. So if it trips you up in the front, just rewrite it in the back. Okay, so we know that this guy is our shift. It's opposite, so it's negative, so we're really going right. And then we said 135 degrees, we're in radians really, so we're going to be going right 3 pi over 4. I don't have to do any division. I could set this thing equal to 0 and it's as easy as just adding over the 135. Okay, if that was a different number in front of there, you'd have to set it equal to 0 to get your shift on the right. And then remember, this shift just follows. So we're also going to go up 1. Okay, let me reiterate this. So going back, sine, cosine, tangent. When we were graphing sine, we moved that point, correct? When we were going with cosine, we were moving this point. When we were doing tangent, we are moving this point. So we're moving whatever is on the x and y axes, or if you really think about it, it's just the y, right? Just so happens that these guys are the origins. So think about what is happening at that xy meeting spot. What's happening at that origin? On a tangent graph, I just drew it down here. I don't have to redraw. This is a tan. On the tan graph, it's the 0, right? So that's what we're going to be shifting, is that 0. And we're going to be plotting zeros every pi from there. All right, let's stop talking. Let's start doing. All right, so we know tan. I'm just going to redraw that guy right here. Positive, if you're right here, it's a positive graph going up the slide. And then this is pi over 2. All right, so starting, let's draw our starting graph and then we'll shift. So our starting is at 0, 0. Our period is just pi, so we're going to have another 0 at pi, another 0 at pi, another 0 at pi, another 0 at pi. Okay, and then halfway between these zeros, the first set of zeros, is going to be an asymptote. Asymptote, 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 and I just draw a line for the asymptotes. Okay, now let's do our shifts. So remember, the negative means we're really going right, and we're going right 180 degrees, which is 3 pi over 4, which really in this case is, what did we say? 4.5 units. 4.5 units. Okay, and then don't forget about this guy. We're also going up 1. Okay, so let's graph that. So we're going to take each of our pieces. So we're taking this guy and we're going to go right 4.5 units. So 1, 2, 3, 4.5. And we're going up 1. And cross that off. Sorry, I should have crossed off before I moved it. Asymptote, we're going to move 1, 2, 3, 4.5 units up 1. 1, 2, 3, 4.5 units up 1. 1, 2, 3, 4.5 units up 1. Let's do one on this direction as well. 1, 2, 3. So these are 3 units apart. Okay. Now you can keep going in the direction. Let's draw some asymptotes first. Positive tan, so we're going up. And it keeps going in that direction, or that manner. And that is your tan one. Oh, do you guys see this fun one down here? Don't worry. We'll be doing that fun. We don't want to leave out any fun for more fun for you. Okay, so let's look at this guy. Write him down. So we have y equals -1 plus 2 cotan x plus pi over 2. All right, so we got a cotan. We got the 2, which we don't really care about. Remember, amp. It's none, even though there's a 2 where there usually is an amp. This -1 is the same thing as putting it back here as your d. So I'll do that on this guy. If it doesn't bother you up front, leave it up front, doesn't matter. Okay, we have to worry about period. So period on tan and cotangent is just pi. Pi divided by, oh, it's 1 again, so we're just going to get pi. Which means something important is happening. Every half of a pi. Because remember, we used to divide by 4. This on tan and cotan, we only divide by 2. All right, let's do some shifting. So we have 2 we don't care about. This guy we care about. This is a 1, so we don't really have to set it equal to 0 and do all that if we don't want to, because setting this thing equal to 0, easy enough, moving it over. So we're going to get pi over 2. It's a positive, so that means we're really going to go left. Pi over 2. And what's this -1 mean? Down 1. Okay, and then don't forget, based on these graphs, I think it's easiest to kind of figure out what kind of units we're talking about. So in this manner, we're talking about 1 unit on my graph is 30 degrees. This is pi over 2. Pi over 2 is 90 degrees, so this really is going to be left 90 degrees, which is 3 units. And this one's going to be down 1 unit. Okay. Just like we talked about all this, guys, right? So now let's think about cotangent. Cotangent has an asymptote here, an asymptote here, into 0, and it's not tangent, it's not positive, it's negative. Okay, so we're going to be moving this asymptote. All right, so let's look at the stuff that we have. Let me draw my little graph really quick. Asymptote and negative. Yeah, okay. If this was a negative cotan, then it would really be up like a tangent function. Okay. Okay, so we're moving our asymptote. Let's figure out where our original is going. So a period is pi. So it means this is happening at pi. This is happening at pi. This is happening at pi. Goes on forever in both directions. Halfway between 0 and pi. Halfway between 0 and pi. Halfway between 0 and pi. Okay, and then we said we need to go left 3 units on my graph, which is really pi over 2. And then we need to go down a unit. So we're taking this and we're going to go left pi over 2. 1, 2, 3. So my new asymptote, and then we're drawing it down 1. It's right there. Left 3, down 1. Left 3, down 1. Oops, forgot to cross them out. Left 3, down 1. Left 3, down 1. Okay. So we said something important is happening every 90 degrees. Oh, look at that. Every 90 degrees, it's an asymptote or a 0. Draw your asymptotes. Okay, and then we need to draw our function, which is looking like this guy. And there is our graph.